Welcome back. I hope you enjoyed that short break, how long it was, and you were able to stretch your arms a bit and try to get that energy back flowing. So, thank you for coming back and staying with me to learn about the rest of the day. Now, let's get into learning about the GPIO programming structure. What is the programming is all about, and how you're going to use the GPIOs in the programming. So programming structure shown here is connected between bus 2 ports. As you would remember in the functional block diagram, every GPIO, I'll show you by using the, sorry, I'll go to the data sheet. This is page 15 on STM32F411. And if you come to the data sheet, these are all the GPIO ports, port A, B, C, D, F, H, and this is connected via the AHB1 bus, advanced high performance bus, and that via that bus that's connected to the ARM Cortex M4. So these are all the GPIO and the port pins that we are learning about. So it's connected to the bus and the bus connected via the port. So that's what here it indicates. Bus connects to IO port. And there are several registers they are used in the GPIO programming. First off in the rank is direction register. You have to say what direction that register is going to represent. So when you consider direction register, there are 4 different types of direction registers. The same register can be used as an input. By default, all the GPIO registers, the output registers, come as input. If you want to change and use it as an output, you need to change the code to 01, that denotes output. Whereas if you want to use that same port as an alternate function, then if you turn the program to 10, then it can be used as an alternate function. And also you can use that same port as an analog function if you write 11 to the code. So I will explain to you in this. First, I'll explain what all this, then I will show you the registers. The second one is the output type register. What is the output type register? So far, we learned there is 2 types of output type registers, either a push pull output type or an open drain. Push pull got both transistors, PMOS and NMOS. Open drain got only NMOS. Push pull got 2 states, 1 and 0. Open drain got 0 and floating, it doesn't know, so sometimes it can be the high impedance state. So that's that. The third is the speed register. When you want to switch the register between the transition state on a tri-state between zeros and ones, you need to see that fluctuation. So that's where the speed registers are used. And there is input data register. The input data register is the one you use to read any data from that particular pin or from that particular port, particular pin, which you will learn in the next session about using IDR register. And the output data register ODR is where you're going to write to that pin, so it can be used as an output pin and you can see the value at the output, and that's that. And there is configuration registers, which you will learn when I show in the next few slides. How does the GPIO subdivision stand in hierarchy? As you can see, GPIO pin can be classified into 4 different usage. If you like to put the word, can be used as an input pin, can be used as an output pin, it can also be used as an alternate function pin, or it can also be used as an analog pin. When you take as an input, you can also connect an interrupt to that input that you will learn. There is a separate session for learning about what is interrupt. You will learn about that, and so this is a hierarchy about GPIOs. And these are all the registers you will be learning just briefly in a while. So there is GPIO port mode register. There is GPIO port output type register. As we learned there is two different types, push pull and open drain. And there is GPIO port output speed register, there is pull up pull down register, input data register, output data register. You can either set the bit or reset the bit register, and alternate function can be divided into two, low register and a high register. And there is a GPIO register map where you can see through this and see where and which register is mapped, which I will show you shortly. So every GPIO port mode register will have these three values, and these three values are the must. Every register will come with its address offset, it will have its reset values, and it will tell you what mode it is. So these three are in the port mode registers. I'll show you this. Okay, this is the input configuration GPIO pin, the basic IO. It's in the data sheet STM32F411. So let's go into the data sheet. I will see. It's GPIO pin basic IO. GPIO pin basic IO. GPIO pin. STM reference manual. You got GPIO pins. General purpose IO. So again, I would advise you to download this data sheet and go through the GPIOs starting from page 142 downwards to up to I think 160. So this is the diagram where it shows how the input driver is connected and how the output driver is connected. So on any time the Schmidt trigger TTL logic always comes into play. So with this, whatever signal you send through gets through the Schmidt trigger, and then it saves the data in the input data register in the input driver, and the data saves in the output data register in the output driver. So you can write to the output data register and you can read from the input data register. So that's what it says. And as we discussed earlier, it can be used for 4 different types or hierarchy, if you call. One is an analog, one is an alternate function input, and one is you can either use it as an input or you can use it as an output. So that's what it says here. GPIO. So now we're going to get more into the GPIO. So as I said, we can use it as alternate function. So this is a very good example. For pins 8 to 15, that's that for pins 8 to 15, and this is for pin 0 to 7. It can be used for timers, or for example, if you use a alternate function 4, it can be used for I2C1. Also the same pin can be used for I2C1 pin 3 or I2C and timers. So the same pin could be used for I2C or SPI. So that's what alternate function is. Moving along, so that's the input configuration. So the input comes along and it receives Schmidt trigger and it stores the data and got read from the IDR. This is the output configuration. The data comes through, and by default it's set up in this one is set up in push pull, so it gets the output as PMOS gets active, and the output data got read and saved in output data register, and you can either write from there. And this is the alternate function. After it comes through the Schmidt trigger in the input, it acts as an alternate function. So you can change that to using the same pin either as an I2C pin or SPI pin or CAN bus. In the CAN bus you can use the same pin, so that's what this is. And the analog pin is what you get the value. If you use it in front of Smith trigger, then that's considered as an analog setup. So these are all the input variants that I told you about earlier. Now let's see one by one the GPIO register. As I said, the GPIO port mode register got the address offset 0 cross 0 0. It has two ports, port A and port B. And the reset values for the port mode register is 0C00. So as I said, port mode register is a directory register. In other words, you can set that mode into this following 4 states. If you write 00 on bits mode 1 and mode 1 of 0, if you write 00 here, then that means bit 0 and bit 1 as 0. That means it is configured as an input state. I'll keep it okay like that. If you write 0 1 here, 0 1 here, then that means this port is set to as an output mode. If you write 1 0 here, then it's an alternate function mode. If you write 1 1 here, then that's an analog mode. And this is the GPIO port out type register. As we learned, if it is 0 on bit 15 to 0, if all these bits are 0, then that's in a push-pull state. If all these bits are in 1, then it's considered as an open drain, and its offset value is 0 by 04. This is a speed register. If you set the bits, that is 1 to 0, if you set this to 0 0, then it's a low speed transition. If you set to 0 to 1, then it's a medium speed transition. If you set these two bits 1 0, then that's a fast speed. 1 1 is a high speed. And this is the push-pull register. As we learn 0 0, there is no push-pull. By default, it comes as push-pull, so you don't have to do anything. So only if you want to use in open drain configuration, then you have to use this register, pull up or pull down, because as you know, open drain has only ground or floating as 2 states. If you want to get anything closer to the VDD or VCC value, then you need to set, if you're using as a pull-up register, then you need to set these two as 0 1 or 1 0, and 1 1 don't bother if it's reserved. And the next one is GPIO input data register. It's IDR, and its offset value is 0 cross 10. The next one is GPIO output data register, where you can write to this register, and these bits can be read and written by the software, and its offset value is 14. And this is the bit to set either set or reset. And port configuration lock, you don't have to worry. Okay. GPIO, when we learned earlier that it can be set as an alternate function low register or high register. For a low register, the offset value is 0 to 20. Sorry, 0x20. So when you write the bits 31 to 0, and these bits are written by software to configure alternate functions. So they take it as 8 bits. 32 bits is converted to 8 bits, and they come up with this to use alternate function. So for instance, if you want to use AF7, it has to be 0 1 1 1. So how it works is, divide this 32 into 4 of 8 portions or bits. Then you need to make 0, 31, 30, 29, 28, 27, 26, 25, 24, 23, all this to 0, and the rest all 1. That means you are using AF7 on a low register. 20. Whereas when you come and use in high register, if you keep the offset as 24, and again if you set the bits from 8 to 15, okay, 8, where is 8? 0, 8, 1, 2, 15, okay, and these bits, they're taking it as an alternate function high, 8, 12, 13, 14, 15. This is alternate function low at 0, 1, 2, 3, 4, 5, 6, 7. So let's see alternate function. We talked briefly about the GPIO register mode. So the GPIO moder comes with an offset, and it tells you which mode belongs to where and which pin is connected to where. So we are only using the GPIO moder to tell whether that is going to be an input or an output or alternate or analog. And if you use as a output typer, then you need to set the offset as 0 cross 04. This is like a summary of what we know. This is given on its own, like individual register explanation. But when you come to the register map, it gives the overall. And it's like a table, truth table if you like, something like that, which you get everything in one table. So that's what this is, register map. So we explained this, and this is the push-pull configuration, and we learned about the input function, how it operates with the Smith trigger. In the input configuration, what are all the steps to be configured as an input mode. The output buffer is disabled when the input pin is programmed as input mode. The Smith trigger input is activated. Data present on the IO pin are sampled into the input data register for every clock cycle. Every clock cycle. Read access to the input data register provides the IO state. So you can access to the read to get to read it. This is the output GPIO pin. It's by default, it comes as a push-pull because there is a PMOS and an NMOS that we learned earlier. The data gets sent and gets stored in output data register. It's ODR. If you want to learn, I just showed in the reference manual. The reference manual just is said. Okay, the pages are from 140 to 160. If you go to the reference manual, then you will learn about what I said. So I advise you to download the reference manual and start to read and get yourself more familiar about what registers are used and where it has to be used. And this is the open drain connection. We also explained about when it used as an open drain, then you need to use an internal or an external pull-up resistor to connect to the VDD. Summarizing why IO programmed as an output, read access to the input data registers gets the IO state, read access to the output data gets the last written value. And the weak pull-up and pull-down register can be used by PUPDR register, PUPDR register. And this is about the alternate function that you just saw. Alternate function low, alternate function high. Alternate function low starts from 0 to 7 bits, and alternate function higher starts from 8 to 15 bits. Out of the 16 GPIO that we talked about and learned about, the first 8 bits, when you want to use that as an alternate function, that's considered as a lower, and the last of the 16 bits, the last 8 bits, it's considered as an active high. Alternate function high, sorry. And this is analog GPIO pin, which I talked to you a bit earlier about. So the input gets in and it got read before it hits the Smith trigger. The output type, there are 2 types, as you know, push-pull and open drain. If it is 0, it is push-pull. If it is 1, then it is an open drain. And its offset value is 0x04. And the output speed register, the 4 different speeds, and its address offset is 0x08. And the pull up pull down register I showed you early. By default it comes as a pull up pull down one on a push pull configuration, being an output type. Only this register is used if open drain output type configuration. So if you want to use it as a pull up, it's 0 1. If you want to use the open drain output type configuration as a pull down, then you need to program as 1 0 here, and its offset value is 0x0c. Input data register, its offset value is 0 cross 1 0, where you get to read from that IO port. And the output data register, the offset value is 0x14. You get to write to that pin so your data can be seen. So the alternate functions, the first 7 bits are considered as the low, and its offset is 0x20, and the bits 8 to 15 they are considered as the high state alternate function 0x24. And this is the alternate function mapping that if you go to the data sheet, I will show you where the alternate function is. So this is the data sheet, and going to page 47, I humbly ask you to download STM32F411 datasheet and STM32F411 reference manual, either from STM32, or I can post it in our Facebook group where you can download, and you need to read, because this is very important, because as you can see, the port A, the pin 0, can be used as a timer, and it can also be used as an UART2. For example, pin 7, it can be used as a timer one, it can also be used as a SPI. So likewise, every pin has its alternate functionality. So please refer to this chart, this table, and you will familiarize about the alternate function. If you take PB3, it can be used as a timer too, and it also can be used as a SPI, and it can be also used as an I2C. So likewise, every pin has its multiple functions that you can use. So that's what it denotes. And that's the table 9 alternate function. It's exactly on page 47. If you go to the data sheet, page 47, you'll get to read this. And please do so and get yourself familiarized reading it. Okay. Now when we want to write a program to enable to use a port, first of all, you have to enable the RCC registers. RCC stands for Register Clock Control, and you need to enable the bus so that it can communicate to the microcontroller. So that is the only way you can tell which port you're going to use. So you need to enable that port. If you use port A, you need to enable port A. If you use port C, you need to enable port C. So this is the must register you need to consider first to enable, and its offset is 0x30. It's on page 1 and 4. If you go to reference manual, I'll show you the reference manual where exactly this is. One sec. I am in the reference manual, going to page 1 and 4. There it is, RCCAHB1 peripheral clock enable register. So this is what you're going to use. If you're going to use GPIO-A, you need to set this as 1, so it can be enabled. If you want to use B, this has to be set as 1, or C, this has to be, bit 2 has to be set as 1. If you use port D, bit 3 has to be set as 1. So as a programmer, it's your responsibility to see which pin you can most efficiently use in your program, and accordingly you choose that pin and then say that pin to set as enable. So thank you for listening to me so far. what we learned today, we learned about all the GPIO, its introduction, how and where. You learned about its active low and active high, and the yeah, comparatively with LED and switch. And also you learned about pull up and pull down resistor, where it is used and what is its usage and what is its purpose. And also two types of output type configuration, the push pull and the open drain, where the output data can be read in two different forms. The push pull, it gets two states, 1 and 0. Open drain, it's 0 or high state, floating state. And also you got to learn all the GPIO registers, the enable registers, the input data register, output data register, the speed register, etc, etc. So you will be using a lot about this in the next session. And yeah, thank you for listening, and please go through the reference manual and the data sheet and get yourself more familiar about what each and every register does. As I said earlier, it's not only skill set, you also in parallel have to develop your mind as well. So sharpen your dollar yeah, sharpen your saw. It means you need to upgrade yourself to get more out of you, or more out of output that you are referring. So list on 10 activities that you want to upgrade yourself. We are talking in terms of embedded system. Start with embedded system and see what 10 areas that you want to improve. Say you want to learn different microcontrollers, then set that, and how you're going to learn to get that. Or if you want to learn PCB design, how are you going to do that? So the more you invest on you, the more output you get, the more money you can make, and more useful in the company. Or if you want to start your own company, the more you know, the more you can be expert at. And the second one I want to point out to you is, as most of you are all beginners, you're trying to get into the industry, into the market, LinkedIn is the market to develop your professional network. Your network is your net worth. The number of network that you have, the number of people you approach and you talk to them, the more you gain from them, and the more you will learn, and you'll quickly progress and shape your future. And LinkedIn is one very good site where you can get to meet all senior engineers, design engineers, product development engineers, product managers. You just humbly send a friendly invitation request to join with their network, and say you are a beginner, you want to learn about the industry and want to know more about what's happening, the current trends. I'm sure 9 out of 10 will come back to you and accept you straight away, and they are keen to pass the baton to the young generation. So you are the next future of whole. So we would love to express our knowledge and our experience to you, so you pass on your baton to the other generation. So that's what it is. So please concentrate to sharpen your activities and also start to create that network so you can do in parallel. And don't forget to be part of the involvement, as you already knew about it. First write the top 10 goals that get you a point, and write down 10 ideas to try to achieve those goals, and you get another point. And please dedicate at least 30 minutes a day, or go for a long walk, say 7,000 to 10,000 steps, and that gives you 2 points. You get more refreshed, and that gets your brain really thinking when you go out and watch different things. As a design engineer, few things spark out. So when you go out and see different thing, and immediately you see how that's operating. So instead of getting glued inside, when you go out, you also get to breathe fresh air, and that's refreshing for you. And also please spend 15 minutes to meditate and pray, and that gets another 2 points. And 10 minutes to visualize that you actually accomplish those goals, and you get a point for that. And then spend at least 10 minutes to plan for your rest of your day, or for the week, or what's ahead of you in the next week. So, and also spend at least 2 hours. As a beginner, you should dedicate at least 2 hours to learn slowly. Don't rush through, because Most of these are new to you, or if you're coming back to electronics design, this could be new to you and it can be daunting, but don't worry, I'm here to help you all the time. So please take your time and learn, and that will get you to 2 points. I request you to post all your achievements in the Facebook groups so that the others get look at your approach, and they may be able to be really get motivated, and we just help each other out. So that's how it works in the industry as well. And the end target goal is you have to aim to get 10 out of 10. So please be honest and try to practice all of this. This is for your own good and own benefit, and post your achievements so the others can view and learn from you. And there is combo internship coming your way, so please stay tuned. I don't want to push a lot of information with you straight away, so that's why I started this as a beginner, so slowly I can ease you to the deep end of Cortex M4 series. So the next one up is the intermediate and then advanced. So please buy 3 to get the full benefit of M4. And also further along, there is a bundle combo coming up. You'll get all of these courses listed there, and you will be the first person to get the invite to enroll and register to all of these courses. It's on its way, and please stay tuned with A2DG and you'll hear from us. And I take this time to thank you so much to each and every one of you who've been watching this video and learning from me. Thank you so much for your patience, and go and have that lovely break from the screen. And I wish you to have a lovely, fruitful, productive day. It's Arul Anbukarasu signing off on behalf of A2DG. Huru for now. I'll see you in the next session. Until then, take care. Bye for now.